welcome everyone to the end of the first day of Open Ed Week's series of presentations that at least we have. Um, we went through a range of different things today. We're very excited about what we went over. And we're ending this day with a conversation focusing on adapt. And this is actually sort of a mini theme of this week where each of the 5 days between 2 and 3 o'clock Pacific time, we will be going through the ADAPT homework system, which is one of the components of the LibreVerse that you have access to, or people have access to if you have a Libre One account that's connected to it. I'm very excited about ADAPT. We've spent a lot of effort in building this over the last 4.5 to 5 years, and it's starting to really grow in popularity, in potential, and the future success is also quite bright, especially in today's world where things are not as bright in other realms. So anyways, let me get started here, and I will start with how you can access ADAPT. So if you have a URL handy, you can paste adapt.libretext.org into your browser URL locator, and that will give you access to the Adapt infrastructure. If you have a Libre One account, you'll be able to go further than just being able to access the front end. It's open to students who are enrolled in classes in Adapt, and then if you're an instructor with a Libre One account, you'll then be able to tap into be able to make courses, but also to review other people's courses and do searches through the question bank that we have here. So that's a starting point in order to get things going. So let's start with actually a short discussion about who I am if you're unfamiliar with it. I'm a professor of chemistry at University of California, Davis. I've been here since 2005, so I'm about to celebrate my 19th year as a faculty member. My research is on ultrafast laser spectroscopy of photoactive biological proteins. Most of you probably don't want to hear more about that, so I will refrain from talking about that unless you have an interest in order to go into the details behind it. But in 2008, I founded the LibreTexts project. Then it was called the ChemWiki, and it was an open pedagogy effort using students and using emerging wiki-based technologies in order to facilitate large-scale collaborative construction efforts. It's evolved a lot over the years, both in terms of the scope around textbooks and hosting of that, but also into the scope of the other aspects of the LibreVerse, including the homework system that's going to be this topic of discussion, and other components that we have here that I mentioned a few hours ago in a different presentation, including the Commons, the Conductor, Jupyter Notebook System, Antecedent, and other things like that. So the LibreVerse is more than just textbooks. We actually have a full range of skills that connect to it, and ADAPT is one of the critical components of non-textbook related aspects of everything. I'm the founder of the UC Davis Aggie Open program, which is a OER program on my campus. I'm an adopter of OER. I'm an adapter of OER. I'm a creator of OER and a curator of OER. And I emphasize those four things because it doesn't just apply to me, but it applies to almost everybody on our team in that we are practitioners of OER. So we not only talk the talk, but we also walk the walk in terms of using OER in the classroom and identifying what works and what doesn't work. That means that a lot of our perspectives are very much formed by the practical application of things instead of the topical ideal case of how things should operate or how people think it should operate. And sometimes those ideas clash a little bit. And I just wanted to make sure that you guys were aware of a little bit of the perspective of how we evolved. So I do what I do for a variety of reasons. And the primary reason for that is I grew up quite poor. In fact, I was homeless for a significant part of my childhood, living in the back of a truck. And this is a picture of my father's truck that I lived in the back of, at least part of the time, behind a Denny's restaurant. And this is in Linwood, Washington. It's just north of Seattle. And this was my existence for a period of time. What got me out of this level of poverty was essentially affordable education. In this case, here was affordable education at the K-12 level, but I also went to a community college that was affordable. I went to University of Washington, which is a four-year university, which was affordable. I was in Berkeley for a graduate school. I was at the Free University in Amsterdam also is a postdoc, which is a free institution and hence subsidized by the state, in addition to a few private schools here and there that were in there in order to move things forward. But the key point was I always internalize the importance of affordable education in terms of upward mobility. And it's because of that that I'm driven in order to take my position as a faculty member in order to move toward this rather than just focusing internally on my research activity as many of my colleagues do out there. I am driven in order to do this thing, and I will be doing this probably until I can't. So uh, this is not necessarily a unique story. There are many students that have encountered homelessness or are currently encountering homelessness in many of your classes out there. And it's important for us to be aware of the issues that students encounter, both in terms of their education, but the affordability of education and how that can actually impact the resources that they need in order to be successful. Um, so um, the upshot of what we're trying to do is to rebalance the equity gap. And this applies to all of the open community, but it's worthwhile in order to emphasize here that we're trying to remove the financial burden that forces students to pay significantly to get the required educational resources in order to advance. That right there is an economic equity gap where the students that have less money are the ones that are then inhibited from being able to capitalize on resources and move it forward. And that right there is a driving force. But economic inequity is oftentimes correlated to other inequities, whether it happens to be ethnic or cultural that's moving out there. So it's not necessarily just purely a money perspective that's out there. And so OER enables us to do this by providing funds for students in order to be better spent, whether those are better spent for paying for living expenses, paying for food expenses, or other needed aspects in order to be a thriving individual. But from the faculty perspective, OER provides us the opportunity of customizing our resources. Textbooks is oftentimes the example that we go about doing that, but all of the components of our LibreVerse is focused around the perspective of customizing the resources for our needs. Homework is a little bit better organized around doing that thing because no individual faculty member has the same set of questions that other faculty members use, because we have internalized customization in that realm much earlier than we have in terms of internalizing customization for textbooks, for example. But it does provide the opportunity for faculty in order to customize the resources to suit their needs, whether they are the faculty needs or the students' needs in the classroom for class identities and other things like that. So the upshot of why we expanded beyond textbooks is to try to take the place of the commercial publishers' role in academia. And commercial publishers come in by providing faculty with a set of handcuffs, golden handcuffs in this case, where faculty put them in. And once they actually are in the handcuffs, they have access to the textbook. They have access to a homework system. They have access to ancillary materials like a question bank or presentation slides or slide decks, AI, interactives, or a wide range of other tools that are out there. The LibreVerse is meant in order to be able to take the place of the commercial publisher. So it needs to take the place of each of these components that faculty buy themselves into. And the reason that they're called golden handcuffs is that in order to extricate ourselves from these commercial interests in the classroom, we need to give faculty this, the textbooks and the homework and the AI, the answer materials and the interactives and all the realm out there. Otherwise, it's difficult in order to be able to extricate themselves. Commercial publishers understand that very well, and faculty are starting to figure that out as we've evolved moving forward. So we have a broad range off of here, but the upshot of how we operate, both ADAPT and the greater LibreVerse, is recognizing that students are not a market to exploit, nor to make a profit off of. I should say an obscene profit off of. They are not a market nor to capitalize on it. So I want to actually skip my mission statement because I oftentimes enjoyed doing that. I want to talk about the actual homework system itself, because that's the gist of what we're doing here. And if you have an interest, I can go back into the bigger picture that we have here. And the question that I would pose here in terms of building a homework system is, how do you build a homework system that complements the utility of the infrastructure of the textbooks that we host within the LibreText, which is flexibility and broad scope and free to access, or as cheap as possible to access. That includes, again, like I mentioned, flexibility, dynamic, comprehensive in nature, integratable, LMS agnostic, powerful, and free or nearly free. In other words, not making a profit of what we're trying to do. And the answer to this is essentially very slow, because it's a very slow, time-consuming process. We're 5 years into this, and because we took a lot that we bit off, it's taking a bit of time in order to advance it, but things are really scaling up now with many classes that are using it and contributing to it so that everyone can actually benefit from here. Underlying this, just like most open source technologies, is the sharing is caring model, the model that underlies OER. Once someone has created something, they share it to the community is able to capitalize on it and move forward. In this case here, it's other code bases or other technologies that we fold in. In other words, don't recreate the wheel, because it's silly in order to go about doing that. It's wasteful. And that's how we've addressed what we're trying to do, is not to actually build things unless we have to. And we do a lot of building off of here. So the Adapt homework system uh, has about 300,000 questions hosted in its corpus. Those questions are distributed in between 4 primary technologies. Uh, each of these technologies are open source, and you can identify separately, but we put them all under the same envelope so you can actually benefit from them collectively. So that includes WebWork, which is a technology from upstate New York, meant for addressing algorithmic mathematics and engineering. It's mostly focusing on upper divisional math classes. It's especially popular on the East Coast of the United States. iMathAS has comparable technologies as WebWork. It's the technology underlying MyOpenMath. That is more popular on the West Coast, and especially more popular in the community colleges. David Littman was the one that created this technology from scratch. He deserves a lot of credit for being able to do these things. The people that actually were involved in WebWork, which are multiple people out of the University of Rochester. Mike Gage was the point person for the longest time, but it's more of a community-based project now, have also deserved similar credit for what they've done. Uh, H5P is a newer technology. It was born north of the Arctic Circle in Norway, and it is an open source technology for building interactives, especially visual interactives that you can then embed into your textbook or embed into a homework infrastructure that can pass grades back to your learning management system. There are issues associated with H5P that need to be addressed because it's not by itself intrinsically a homework infrastructure, but it can be used successfully if you use it in an appropriate manner, which I'll talk about later on. And last one is native technologies. Native is a very catchphrase term for technologies that we built into Adapt that are not any of these 3. So that includes things like QTI, question and test interoperability. Those are the questions that are part of your learning management system. So if you're sitting on a question bank in your learning management system, you can contribute it to our corpus, and then it's hosted within this right next to other questions that have greater power, because QTI is relatively limited in its capabilities, whereas WebWork and iMathAS, and especially H5P, all have more powerful capabilities. And being able to have all 4 of these question types together provides an opportunity for people to benefit from those questions. So in other words, if you want a question that is made in iMathAS or MyOpenMath, but you tend to use WebWork, it doesn't matter with Adapt because you can make an assignment with both those questions simultaneously. Students interact with it. They don't need to know that they are different technologies underlying how they work. Same thing with H5P and native type. It's quite common in order to make assignments. That's a mixture of different technologies that are over here. And as a faculty member who's adopting these questions, if you're not actually involved in creating the questions or modifying the questions, but just reusing them, then it doesn't really matter if they're created with different technologies, as long as you're able to move forward. Um, so that those are the auto-graded questioning capabilities in Adapt, but we also have open-ended questions capabilities. Those are questions that require a student, grader, or a instructor in order to be able to evaluate a student submitted report, sort of submitted value student submission, that is, in order to assign a grade. So it's open-ended graded. That could be rich text, that could be audio, that could be files and various things. It will be integrated into the antecedent-based technology soon, so that when students can actually submit and write in a lab report or an essay online, then the grades can be passed back automatically to Adapt in a centralized manner. And if people are interested, I can actually show a little bit more about that later on. It's actually really quite a powerful technology. Um, so the upshot off of here is that Adapt is designed to be very flexible. Uh, and that flexibility then maps into utility and power. So that if you're using this class or using Adapt, you can use it for entry level, freshman level questions, or you can go into more advanced upper divisional classes that require that auto grading is not the ideal way in order to grade or to have submissions, but having it centralized provides the mechanism to benefit from the Adapt infrastructure. Um, So just a little bit about how homework sets are put in place, just to give you the definition of how we not an underlying organization of how we are put together. Any of these technologies stand alone. You can find, and they have a range of different modules that are necessary in order to be able to run that, including a problem builder, a problem library, a problem searcher, assessment delivery, assessment checker, gradebook, and LMS. So when you adopt a homework system, you learn each of these modules and their unique way in which they operate for that homework system. But if you had a different homework system that had similar capabilities or different capabilities that complement the one that you're doing, like instead of web work but iMath AS, you need to learn a different problem builder, a different problem library, different problem searcher, different assembly delivery, et cetera, et cetera. And then you may have H5P, which has its own set, and QTI, which has its own set. And the approach, the issue that I'm trying to bring up here is that no one tends to master all these technologies. Uh, and for that, because the reason you need to learn all these different components, and you don't typically bounce between one and another, although there are some exceptions off of there. So what we're trying to do is we take all these things and put them all underneath the same envelope, the same Adapt infrastructure. Centralize the problem library, centralize the search capability through the library, centralize the gradebook, centralize the learning management interface. So now each of these technologies acts as what's called microservices, uh, which provides value added capabilities to the Adapt system, but everything else is the same. So that means that an instructor that uses Adapt in their chemistry course, for example, in my chemistry course, the students that take that class, if they then go into not chemistry, go into a Spanish course, they have the same interface. Uh, and I can then help that instructor in terms of understanding Adapt through that same interface. So it reduces the faculty cognitive load, but it especially reduces the students' cognitive load. No longer are they bouncing around or have to bounce around from this application, this application, this application, this application, which has even gotten worse with AI. Now everybody and their uncle has some AI company that they're trying to cram down OpenEd's throat because they make money off of that, but bring things together into centralized infrastructure in order to be able to facilitate that. And that's a guiding principle behind how Adapt operates. So Adapt is designed for multimodal use. Students can submit results by going directly to the Adapt website, the URL that I mentioned before, but we can also embed the questions from Adapt into your textbook. Especially if that textbook were a LibreTexts book. So that gives you the opportunity in order to make your textbook into the homework system. And if you feel that students are not reading your textbook, you're probably right, they are not. But if you actually make your homework system the textbook itself, you'll provide a greater opportunity for students to be engaging with the content in the textbook itself. Now, there's no study out there in order to argue that this happens to be this lower efficiency or efficacy than this approach. I just believe that this is the case that's out there. The idea behind here is the greater that you can increase the engagement between the student and the material, in this case here, the textbook using engaged homework system, the more likely they're going to be reading. And typically there's a strong correlation between engagement and learning. Other modalities of interacting with this includes our phone app. So we have a phone app that's available. It'll come out in the stores very soon. We're just doing a few final tweaks off of there. It provides an opportunity for students in order to do homework in a native environment on their phone. But it also substitutes as an in-class polling system. So in other words, it could take the place of iClicker or Turning Tech or other technologies that are out there, and it will fold those scores directly into your into Adapt and then pass it back to your learning management system. So students can actually benefit financially from not having to pay for Adapt, but also not having to pay for iClicker. Uh, and it turns out that those costs are actually sometimes comparable to the homework system, although it's unclear to me why, except for economic supply and demand sort of case, because this technology is significantly easier than homework. So you have access to that right now. And lastly, irrespective of how students interact with their problems and submit scores for them, they can pass back the scores to your learning management system if you have it hooked up with that. And we have it hooked up with most of the major LMSs. The last one that hopefully is handled today or tomorrow will be D2L. So you're able to use it in a dynamic manner off of that. If you decide that you don't want to use it with an LMS, you can use it completely on Adapt, download scores directly and via CSV file, an Excel-like file, and then move and upload it to whatever source that you want to have in order to be able to move it forward. I personally do everything on Adapt. I don't use it with my Canvas LMS because Adapt has greater features for analysis and for keeping track of student performance than what Adapt does, because than what Canvas does. So this is a snapshot of a question. In this case here is the H5P question that's embedded into a textbook. This is a nutrition book from Kansas State University, and the students just basically do their homework directly on here. I mentioned I mentioned that the phone app is available. This is a video of the phone app. Um, and again, it's a native technology, so it's not just being able to look at the web version of Adapt directly online, and it provides again the opportunity in order to not just submit scores, but to also be able to use this for polling. So when we open up a question and when you use Adapt in a polling mode, it will then send a notification to all the students, whether they're on the phone or the computer, and they can then answer the question right there. And that helps to provide greater interactions between the faculty and the instructor in the classroom. Again, following through with the whole argument of the greater the engagement, the more likely the learning happens to be there. Plenty of justification behind active learning in the classroom. This is about to pull up a question that is in chemistry, and it's specifically a distillation question, and it did not pause there, so I can't do it. But it's basically a distillation question that you can pop up in order to be able to answer it relatively quickly and effectively. That's off of here. This right here will substitute into something that should be released in about a month to a month and a half, which is the opportunity in order to use the phone as camera in order to be able to take pictures and upload results. Now, that by itself is not necessarily that stellar of a technology. I wanted to use this for my lab, so I have students take a picture of their lab setup, and that is part of what they actually upload in their homework, or not their lab report infrastructure. But the camera can also be used in order to take a picture and upload a drawing of something, for example, of a molecule, and then we can do some things with that and with some machine learning, basically the poor cousin to AI, and I'll be talking about that in a moment here. Adapt has two modes of operation for distributing questions to the students. And we're talking about expanding this. One is conventional, where we have, here's a course, students are enrolled in the course, here's an assignment, the assignment's open in this date, is closed on this date. Each assignment has X number of questions. The students do the questions. They're auto-graded or they're open-ended grading. If they're auto-graded, obviously the Adapt's infrastructure grades it and puts it into the grade book. If it's open-ended, it's uh, uh, it's relying on a human in order to come in order to be able to submit the score. That's pretty straightforward. But Adapt is called Adapt because it has adaptive learning capabilities, and that involves learning trees. And the idea behind a learning tree is instead of giving a single question, you give a question and then you have a follow-up set of nodes, where a node consists of either exposition, description of something or video of something, or an assessment node behind it. So this is a question dealing with some complex issue dealing with proper significant figures in subtraction. If the students fail that, they can get the opportunity in order to redo this question, but they have to spend some time in the learning tree. And the idea behind the learning tree is to decompose that question into the constituent parts of the question that one needs to master in order to be successful with that root question. And that involves some training, professional, some not professional though, but some exposition. That could be text, that could be a video. Uh, After a little bit of training for that specific subsection necessary to master that, they get an assessment to see did they actually master that question, that subsection, that subtask. And if they did, they get a do-over and they can come back up here again. So the idea is this acts as a virtual tutor of sorts, but it's a virtual tutor where the student is the one that guides their own education. So they can decide which pathway they want to do based off of what their knowledge is of the specific topic of each of the pathway. And that gives students agency. And that's what's missing in most adaptive learning infrastructures is the agency. And and from that agency, you get engagement, and students are more likely to learn from the case there. There's plenty of evidence to show that this is a superior way in order to do this than the conventional way. The problem is that this takes a bit of effort in order to be able to formulate. And we've been building these trees for a while, and we look forward to building many more in the upcoming future that you can capitalize on with and run forward with it. So we have different technologies for different purposes here. I'm going to skip over this because it's not overly important for the sake of this conversation. Even though we do have a bit of time, it's a bit more nuanced than what we have. And I want to tie everything together into one big bow here. And since we do have time off of here, I can start to open up the ADAPT system and show you it real time. So we have a range of different types of technologies for handling auto-grade capabilities. WebWork, IMathAS, H5P, QTI, open-ended infrastructure. Those technologies are all folded into ADAPT. So we run the equivalent of MyOpenMath and WebWork as independent servers, and H5P as an independent server in QTI. So it's a much more complicated infrastructure than just basically a single application that you download onto your computer. You could take the questions that are housed in ADAPT. You could put them into your textbook, either formatively or summatively, where summative means the students need to sign in order to get access to the question and to show that they have done it. So they're using it as a homework, or formative when it's just practice. Uh, your textbook can actually be embedded into the learning management system if you want, or students can access the textbook directly on our website. Then the scores from ADAPT can be passed directly into learning management system via LTI or via the LMS's API in the case of Canvas in order to give more powerful interface than what LTI does, so that everything is all in your LMS. So it's a complicated infrastructure. We try to hide as much of the complexity behind the scenes so that the end user doesn't know about it, but yet the end user can benefit from the corpus of questions that we have from WebWork, which is about 50,000 questions, or what we brought from MyOpenMath, which is about 50,000 questions. And so all total is about 300,000 questions that we've curated or integrated within our infrastructure the last 5 years and continue to grow. I mentioned the studio. I oftentimes like to point this out that if you go to studio.libretext.org and you have the same account that you use for ADAPT, you can come in and you can use that as a mechanism for creating interactives. This right here is useful or to emphasize over the other technologies because many people use these things for formative use, that they embed these questions directly into their LMS and completely shortcut ADAPT. But we do consider Studio to be a component of ADAPT when we actually talk about this as a whole. This is what the application looks like. And again, since I have plenty of time after I go over this discussion, I'll pull this thing up real time with a single courses, and I have a few shown things. We've changed the update since this screen has been made in order to have a few more advanced features connected to it, but it has the same general aspect that you would expect as a starting date and an end date connected to various questions, various things. This right here is my general chemistry course, and this is my graduate chemistry course and such. Now we collect lots of data on how students interact with the material on the LibreText. Part of that involves how they interact with the textbook, if you decide to flip a switch in order to keep track of it. Part of that involves how they interact with the ADAPT homework system, if you decide to want to capitalize on it. This is one example of some of the data that you can have. This is not actually an ADAPT example. This is the homework example. And this is something that we published about a decade ago, in which, and this is actually by Gregory Allen, who's going to be talking later on this week on his use of ADAPT in his Mendocino College chemistry classes. This is when he was a graduate student at UC Davis. So in this case here, we were tracking how students were using the textbook. And what we identified is at the start of the term, students started reading the textbook. And then they started to stop reading the textbook until the first exam came up, and they read a lot, and then they stopped again. And they read a lot and stopped again at each of the exams. Now, this is not necessarily surprising. This is just standard studying behavior that you're going to be studying beforehand. What the issue is, if this is cramming, if students preferentially only study right here and don't study back here, this provides a mechanism to identify the detrimental impact of cramming. We did this and we identified the students that crammed were performing about 10% poorer than the students that didn't cram, at least on the exam that they were cramming behind here. The long-term effect is unclear from us using these data, but we now have enough information to be able to start addressing them. From this, and from a desire to reduce the impact of studying here and down below, I started to switch the pedagogy around here. So that means it's actionable. In this case here, I used weekly quizzes instead of midterms in order to try to reduce the cramming. That sort of feedback infrastructure is baked into ADAPT in order to identify questions. This right here is looking learning analytics on a specific page. I should be pulling up this at the question level. Unfortunately, I don't have it, but we can identify how students are studying, how much time they're spent studying, or doing problems on ADAPT, or if they're actually going back and studying the problems afterwards using ADAPT as a homework system, using it as a learning object instead of just as an assessment object. This right here is one feature of ADAPT that's going to be coming out very soon, and it's part of our organic chemistry sequence. So we worked with an individual in Amsterdam, Herman Bergwolf, who created this infrastructure called MolView, and he has a Sketcher-based system that he's working on with us in order to make it so that we can construct molecules two-dimensionally. Yeah, we could see it three-dimensionally if we want to go about doing it, but more importantly, we have the ability in order to submit these things for questions. So it's the starting point of organic chemistry questions within ADAPT, which is a fundamentally different infrastructure than math-based questions or algorithmic-based questions that you get in general chemistry that's out there, with maybe the exception of things like Lewis dot structures, which have a little bit more structure off of there. Now, the going back to what I was talking about before with the phone app, we have the ability in order to take the phone app and make it so that when someone uploads a picture of things, we can then do machine learning in order to take a drawing of a molecule and then create the molecule three-dimensionally. Now, this is using augmented reality, which we're not planning on doing it, but we have the ability in order to take a picture of this thing, upload it, and it goes into that organic chemistry sketcher. Now, so one of the problems that people have, and this also works with pictures if you want to do it, so you could do a cup of coffee and then get caffeine that comes from that, which is not coming up here for some reason or another, or so. But for those of you that are familiar with organic chemistry, the effort in order to create a molecule here online is a bit more time consuming than being able to do it on a piece of paper. Right here. This provides an opportunity for students to be able to draw something on a piece of paper, take a snapshot, it takes this thing and then pushes it into the two-dimensional sketcher. And that makes organic chemistry a lot faster for students in order to interact with, and hence makes it a lot easier in order to use before. And we're very excited about this prospect of being able to put this down so you can actually go through a lot more complex more complex molecules without having to spend the time of trying to build it online. And we have most of the infrastructure in place in order to be able to roll that out by the end of this month, at least on an initial basis. Yeah. One of the other technologies that we're introducing to here is in collaboration with uh, uh, California State University San Bernardino, which is to build a virtual dissection infrastructure, a tool that can facilitate dissecting out three-dimensional models. In this case here, a skull. So anatomy was what we wanted to do. Being able to separate out, you can start to ask questions like identify the mandible or identify this bone that does this thing or that thing, or name the various things. Stuff that was very two-dimensional can actually be formulated in a three-dimensional picture off of here in order to be able to manipulate and structure this. This is outside of chemistry, and this is more for three-dimensional objects like anatomy. You can imagine doing this for physics classes, you get architecture, anything where spatial organization is particularly important for that. We're working with Riverside Community College District down in Southern California to do something like this with being able to decompose a computer infrastructure for computer information systems. So you can actually add computer parts together in various ways that are just difficult in order to be able to do with just simple two-dimensional behavior. So let me end with what I skipped over in the beginning, but it's actually worthwhile for me to give down, which is our mission statement. And this applies for everything, not just Adapt, in that we're implementing a community-built platform for the construction, curation, adoption, and adaption of OER that's comprehensive, can be curated at multiple levels. In this case here, the OER we're talking about is the question types and the technology that are out there. And again, we do what we do because we believe that students are not a market to exploit, nor to make a profit off of. And with that, I have about 20 minutes left. I'm happy to answer any questions. I haven't seen any questions in the chat. Otherwise, I can actually go to Adapt directly in order to be able to show you some of the things that are behind here. It's up to you guys. What would you guys like to do? I presume there are people there. I see you guys. Yes, Mohammed.
Quick question. The app that you said that people can draw on paper and take a
Yeah.
snapshot and convert it into molecule, is it still out there for use or it is still in development?
Um, so the half and half. This is a little bit more complicated. The phone app we're expecting to be done this month. So we're just in the final stages of a few tweaks here and there. And part of that is to capitalize on the camera and being able to upload that. The machine learning in order to take the picture and convert it into that image, basically using what's called smiles, it's actually separate from the phone app. That right there is just using an API, at least to start with, and we're going to be using MathPix's API for simple organic molecules. It's not very good for inorganic molecules, but that's a different story. That right there should be available really quickly. In fact, much of the infrastructure is in place. We just have to take a picture that people upload, and they can upload it in old-fashioned, take a picture and upload the file, and still do the same process. So I would expect by the end of this month, you'll have a form of that feature in order to be able to run with. And you can test it out, whether it's part of the phone app, which might take another month to process through the review process in the stores, or you just upload an image that you take a picture of and do it. You'll be able to do the latter quite quickly. So, Diane says she wants to show Adapt, which I can do. Danielle asks, once your institution becomes a member, is Adapt automatically included in the annual membership price, or is it on? Danielle, what campus are you at? Or more specifically, what state are you in? Okay, you get it for free automatically. So it's not part of the LibreNet membership, and that's because the state of California was the one that invested in terms of building that. At least that's what the current state of affairs with that, with things. If you're outside the state of California, then it's folded into LibreNet in some way, internet membership. So again, Adapt is free as a question bank for any verified instructor, irrespective of wherever you're at, off of that. Using it as a homework system in order to go through the calculations, keeping track of the scores and do that like that, requires at least LibreNet membership in order to be able to do. Currently, LibreNet membership is $1,500 a year, which is paltry in the grand scheme of things and even in the finer detail of things, although I understand some campuses do have some issues associated with that level of membership and such. I could talk to you more about the logistics of that at a later date and time if you guys have an interest with it. So let me pull up Adapt. Don't ask me why I was looking at Guns N' Roses. Um, I'm going to go to my Launchpad. This is a snapshot of the greater scope of things of the LibreVerse. I'm going to go to Adapt, and here's Adapt. I just click Login because I've already signed in. Actually, I did not sign in. Now I need to sign in. And I'll do this. Signs as Libre One. That's our primary account that gives you the full access to the LibreVerse. And it takes a moment, and now I am in. So it knows who I am. It has a few additional features connected to it, and here are all the classes that I've used Adapt for. So I've been using Adapt since 2021, I think spring of 2021. Uh, so I started using this quite quickly. I thought I had something in 2020, but yeah, whatever. Uh, and everything that is read is basically closed, so it's unpublished. Everything that is unreaded or doesn't have that hue is available for people to be able to tap into. And I could turn it on and off here. That's the equivalent of publish in Canvas. And this right here is my general chemistry class for majors. So I'm teaching this right now. Uh, and everything that's green is an assignment that students can see. And it started, since I'm on a quarter system, it started the end of the first week. I think it started on the 3rd or so of January, and you can see that I can go through it. Now, I have a lot of assignments. That's because I believe that students should always be doing something in the classroom. Whether it's a small number of questions or it's a large number of questions in the assignment that they need to go about doing these things. So I have these lecture assignments, lecture homeworks that consists of 2, 3 problems that are relatively straightforward for students to be able to see. These questions are all web work. Every question has its own ID number connected to it. This tells me the points. I can look at the solutions and things like that. When I have this little icon right here that's green, that means that this question is used algorithmically. What that means is that every student can get a different version of that question. So if I click on here, I'm looking at this question right here, and it's largely consists of um, awful units, pounds. So much pound players lifted from one to the other. And this right here is just looking at conservation of energy and how you describe work in regards to these things. And these numbers change for each student in the class because I have set it to that. I can turn off that. So that students can't just quickly grab some other student's response in order to be able to do that. All the students got it correct. I have the solution. The solution reflects the actual algorithmic. So it had to do a calculation to find out what the solution is for the question, for the numbers that I put down here in order to be able to do the conversion, and process and do it. Every student who looks at their solution will get a different solution because it has different numbers than everybody else, at least for this specific question. Here's the next question. Here's the next question. These are web work questions. I can tell because it has a slightly different scheme than IMath AS and H5P, but to all intents and purposes, I could switch and choose whichever question I want under different conditions. And see here that some of my students didn't get this question, which was just simple writing. These are not meant to be hard questions, these lecture questions. These are meant to be to make sure the flow is always going, so they don't just study chemistry the 20 minutes before or 2 hours before their weekly homework assignment is due. And that's my pedagogy. Not everyone follows that pedagogy. Um, and this right here then show you the other assignments. I have several assignments coming up. We're in week 8, right? Week 9. So I have basically 5 more lectures left, which includes several lecture homeworks. I do my labs in here. I then have both pre-labs and post-labs put in here. I have weekly homework assignments. The weekly homework assignments involves 10 to 12 different problems, and the students are to solve them. Uh, and this right here is an open-ended question. Student have to submit a file. This right here is a auto-graded question where some of the students I can see the performance of the students. It gives me the idea in order to see who needs help in which condition or what's necessary in order to be able. Some of these are I'm dealing with equilibria, so it's more Le Chatelier's principle if you guys are into these sort of topics and other equilibria in my in this week. I've uploaded discussions and then I have learning trees. So this is a learning tree identifying significant figures. So a student sees one question up here. If they get the question wrong, they can then go into the learning tree. And then here's the learning tree that they have. Here's the root question that they have. Here is a strategy map saying, well, this is the learning tree. It has 4 branches. This is what each of the branch focuses on. Branch 1 is define significant figures. 2 is determining significant figures. 1 is practice problems. This is text and this is video. As a student, I get this as an overview to tell me what I actually want. And they say, well, I feel like I need some training on the definition of this thing, and I can actually read through this and go with it. Or I might need this one, but I prefer a video, so I can embed a video and I can watch the video off of that. I can decide what works best for me in order to be able to deal with the exposition, and then I can deal with the question afterwards saying, did I actually master that part of the composition, and then move off with that. That right there, like I said, is immensely more powerful than a single question, but it takes time in order to be able to draft this and put this thing together. This does give you the ability in order to introduce things that you don't normally would introduce out there. Like, for example, many of the issues that many students have in chemistry right now is because they don't have a great background in math. Yeah. For example, when you're talking about pHs, we intrinsically have to talk about logarithms, and no one likes logarithms. But if you're comfortable with logarithms, you can then understand pHs reasonably well. If you have no understanding of logarithms, or you have a poor understanding, and including exponentials, it's a very painful process. So we can add some nodes here that deals with math, saying, do you have a problem understanding this? And then guide them to say, well, this is what a logarithm is, and this is how it's applicable off of there. And you can start to expand these scopes in order to be able to address what are the issues that students have, and provide the students in order the opportunity to figure out how they want to evolve on the learning trees and such. There are the ability in order to go through and peruse other people's courses. For example, I can go through public courses and I can choose a discipline of chemistry, let's say of general chemistry. Wait a second, I have a slightly different view than, okay, than what you guys do, because I could change it. And here are all the general chemistry courses. And I can peruse and go through these general chemistry courses. For example, I could say the San Bernardino, and what do they actually have? Well, they have 14 assignments. Each assignment has 10 questions on it. I can go in and start to peruse those questions and say, which ones do I want off of here? And this is a kinetics question, and this right here is et cetera, et cetera. This question has been updated since it's been used, and the instructor has the ability to update the question if they want to go about doing it. This gives us the opportunity that we can update questions, but not interfere with other people's use of those questions. It's necessary for doing that in a community-based project like this, instead of a non-community based project. Yeah. And again, the intent of it here is the larger that this happens to be, the more classes that we have, the more powerful it is in order to be able to grab and run with it that's out there. And we're benefiting greatly from here. But in contrast to some of the other fields like web work and iMath AS and things like that, we have these other technologies coming in here that are not just not just calculation based, but have a lot more interactives that are useful in order to address those things, like astronomy or geology or so that's applicable for your classes that might not be applicable to others. So that means that this goes beyond what just simple MyOpenMath would do, or web work or iMath AS H5P, you're taking the benefit of all of them and moving forward. We have access to a handful of other things, including I could do analytics, like I mentioned before. I'm not sure if I don't think I have analytics done for any of these classes or uh, anything else. So, and I think I can't show up any of the grade books or the analytics because I'm going to be showing FERPA protected information, which I don't want to do for obvious reasons. Uh, so. That includes a handful of other things that are really quite powerful in order to be able to move. And unfortunately, I need a fake class in order to be able to do that with fake students submitted it. And we have yet to actually create something like that, although it would probably take an hour or so in order to be able to go about doing that. I will mention in the grand scheme of expanded technologies is a new technology that we introduced a few months ago called Discuss It question types. Discuss It question types will be discussed, I believe, Thursday or Wednesday at 3 or 4 o'clock. I'll let Jennifer or Justin comment on in the chat that Christina Moon from Chabot College was critical in terms of making it into reality. And it basically provides an opportunity for you to provide central core content and have students interact with each other either via audio or video or text on the side. And you can provide criteria that's necessary for them to be able to evaluate in order to get the points that are out there. I have used this in my general chemistry class where I put a very hard question in the center, and I was able to break out the class into groups of 5, and I had them each group in the discuss it question basically would talk about the different aspects in order to be able to solve that very hard question. And I wanted them to be able to work through the thinking process in order to be able to do that. And it also gives them the opportunity to write equations down in the text off of there or provide context and have that conversation that's quite important, I think, for cultivating the educated mind that's out there. So anyways, Justin mentioned here that it's Thursday at 4 o'clock Pacific time. The Discuss It questions are actually really quite interesting, and they're not just useful for different for languages, but they're useful for anything that you want people to communicate with. And that's a key component about how I use my discussions, which are my TA-led recitation sections in my class. Okay, so there are,
Delmar, did you
yeah.
want to address Rachel's question too?
Yeah, Rachel asked, you teach astronomy and geology, the 3D visualization will be helpful for both. Are they built, and do you know if anyone's working on it? So, uh, yes and no. So the geology stuff, we haven't started to build the 3D visualizations, but we've started to look at it and and looked at models that we can download in order to be able to process. So if you could find a model via Sketchfab or other things, and there are lots of the models out there of various um, geology, native geology, in situ geology examples. We can bring it in and bring it together, and you have to identify, well, what do you want with that question? How do you want to use that question? So if you want to be able to say, select the part that does this or something like that, you got to take the model and decompose it into individual components in order to be able to identify that. We're very excited in order to be able to do this. We just haven't done that yet. As far as astronomy works, we've been working with Sonoma State University for expanding their cosmology book. Uh, uh, and there's a cosmology infrastructure in ADAPT. You can actually go through, I shouldn't just tell you about it, I should just show it to you. So the under astronomy, um, where are we? Astronomy. So they have big ideas in cosmology, and there's a range of questions that they have here, and many of them will involve uh, graphical interfaces for being able to manipulate. That's also part of the textbook, and we're at the initial stages of transferring the new JavaScript widgets into Adapt and then being able to put it together. As far as making three-dimensional models within the virtual dissection thing of astronomy, that would require three-dimensional structure of things. And I know that there are people who have that sort of like here is the structure of the Milky Way, that you can dissect it and move it around three-dimensionally like that. I think that that's created. We just need to be able to grab the model and start to actually dissect that out and say, okay, this is the relevant components that you want in order to be able to do it with the model. There are, I should mention here, and I oftentimes do this, but I failed to do it here. So I'm going to paste in the demo model, the demo URL. Where are we here? I got to do it for the assignment. I did this for a course. Here we go. I'm going to paste this into the chat. You can do this right now on your phone because it's a formative question, which means that it's meant for everybody to be able to tap into. You don't need to do it. So these are the sort of questions that you can have, and they're just meant to show some of the features associated with them. So this right here is just a simple, it's a Hess law problem in general chemistry. That's algorithmic. Actually, it's not algorithmic, it's just mathematical. This right here is a IMath AS question dealing with plotting things up in polar coordinate system. You can start submitting right now, and you'd be contributing to this this entry here in order to be able to address it. This right here is a related rates problem using GeoGebra that can be embedded into this thing. It's basically talking about how you move something and what's the rate of one thing change as a function of another thing. For those of you that are up on your differential equation, this is an H5P problem. I can't read Arabic, but it's asking you to be able to drag and drop these things as necessary off here. There are lots of graphical descriptions of, or there are a lot of assessments in H5P that are graphical. Am I missing one? Here we go. Let me see how close I was. I got one right. Ooh. Uh, the problem that H5P has and ADAPT has a mechanism in order to get around it is that that little example I showed here is perfectly fine for students that are not visually impaired. However, the students that are visually impaired, this question wouldn't work at all. And if you want to be able to use this in the classroom, you need to be able to provide an alternative. Well, when you actually build this question and adapt, you have a primary question and you have an alternative question. You can build this question as a series of multiple choice questions. It could be a little clumsy in order to be able to do that, but you could talk about that in order to say, here's a bunch of options, here's a bunch of Arabic terms, and then have people do it in multiple choice. And that, as an alternative, lets you be able to use these questions that are not accessible for 99.9% of the students where they can actually benefit from it. And for the students that are visually impaired, they can switch to the other mode that they can then use the multiple choice version of that. So it provides an opportunity for you to not just say, oh, it's not accessible, I can't use it. It's, oh, it's not accessible. If I make an alternative for it, I can then use it so everyone benefits. And that is part of universal design, and that's part of the ethics of how we should be operating, irrespective of what administrations may be thinking currently in the United States. This right here is a math-based question where you could actually just add some matrices together. And now we start getting into a few things. This one here gives you the ability in order to build a molecule. So you can build a molecule in this way here and submit it. This is not going to be a correct molecule because I need to build one butane, and this is not one butane, but that's not too big of a deal. Looks like some people got it right. And this right here is a link to that virtual dissection system. So I'm going to click on this thing, and it might take a moment because it depends upon how the background is actually set up here. And this will pull up that dissected video. And it's a little bit slow because there's a background added to it. Or it might not be operational because it has not been embedded into it. Like I said, this takes a moment, but it doesn't take this long in order to be able to process this normally. So anyways, I have a little bit of egg on my face, but maybe it'll work faster on your other computer. I looked at it a few months ago, but again, it's not fully integrated. Here we go. So this right here is a virtual dissection, this dissection technology, but it has this background that you're able to put. So you can imagine something like making problems that have the background of your campus. Or other things that falls in line with the identity of your students, specifically the geolocation identity of your students, that they are more engaged with the material because they can actually see themselves there because they can see the front of their classroom where they can see the front of their campus right here. In addition to whatever problems that you have here, I thought that this had the skull here, but instead of the default polygon. But anyways, this is where we can go into like the geology question, where you can come in and start to look at a complete environment and from a three-dimensional perspective, in addition to the thing that's actually formulated here. This I think is really cool. I'm very excited in order to be able to do these things. We would have had these things in to adapt a little bit earlier, but we had some issues with funding. The state pulled a significant amount of our funding last year because of financial issues, and now we are just slowly moving forward with the development that we have, but we are moving forward. And naturally, the more campuses that contribute as members or use ADAPT provides us great opportunity in order to expand the development of ADAPT so everyone can benefit from that. Okay, so I'm a few minutes over. I thank you for your attention. Unless there are any other questions, I can certainly respond. I see Rachel has a question. Uh, uh, if you want to hang around and ask the question, then feel free to do so. I'm fine with this. I don't have anything immediately afterwards, but if anyone has a need in order to go, I encourage you to go about doing so. This recording will be uploaded soon. So
I'll just real quick point out that, as Delmar said earlier, we do have ADAPT workshops on tomorrow, on Tuesday, on Thursday, and on Friday at 2 p.m. Pacific if you want to learn more.
yeah, I'll go into the specifics. This was just more of the introduction to get things going. Anyways, Rachel, did you have you're all good. We can talk about it later on. Accessibility is a critical component, obviously, of how we operate. We take it very seriously, and we've gone through lots of infrastructure, building scaffolds in order to be able to use things in an accessible manner. We're very excited in order to be able to talk about that. So with that, I'll let you guys go, and hopefully I'll see you guys later on this week.